Hello guys, so today I want to talk about what I did to solve the day 7 of the Advent of Code challenge. So I recently made a video trying to solve the day 7 challenge, and it took me more than 2 hours to make this solution right here, but it didn't work very well. I couldn't make a function that iterates through all the folders and get and a function that got all the size of all the items inside each folder. I I had to try another approach. So this is the first code, and this is the second, the one that worked it out. Well, I first I had to read this input and create a tree based on a file tree based on this navigation that is in the input. And to do that, I use this code right here and this function, and to create a tree. Basically, it will iterate through the cds and ls commands to view which directories are inside each other directory, and which files are inside which directories, and create a tree of folders and files based on that. So it's basically to recreate the file system used to create this input. What's interesting about this implementation is that after that we would have to get the size of each folder, and to do that we would have to use basically some sort of recursive function like that will get all possible paths or all possible paths that would lead to a folder, or actually it is that it will get all paths that lead to a folder. Exactly. All possible paths that lead to a folder. To get basically all folders right here. And with the paths we have in this function, we will iterate over them. First we have to remove the duplicates, because right here we would, if a folder have more than one file, it will create, it will add more than one path to the same object. The object here is the object here being the folder, so it will have more than one path for the same folder, which will lead to we counting the size more than once. So we'll get the paths, remove the duplicates, have this total sum, the count, and in the problem have to count on how many folders have under 100,000 in size inside of them, and sum the size of all these folders to get uh, the answer of the question. So we did exactly that right here. One interesting thing about, I think, maybe this part of the code, yeah, is that uh, basically here we recreate the file structure, but instead of having real files and real folders, we just, each folder is like an dictionary itself, is an object, and that has a key, is a string, and a value, it's like key value pair. The value is another object, and this object is all the files and folders that are inside them. So basically, one interesting thing is that inside the same folder, we can't have two folders with the same name, nor two files with the same name. But we can have a file with the same name as a folder in the same directory, in the same folder. So this caused some problems when I was trying to solve it. I was getting the right answer in the example that the advent of code gave, but I wasn't getting the correct result in the test example. That is the input example, and that's because in the example, in the question, there uh, there wasn't a folder with a file and a folder with the same name inside the same folder. And in the input, we had uh, a case like this, a case like that. So I had to add this .dir after the name, after the key of each folder to differentiate it from the file, so it solved the problem. And I think basically is that to notice that a file and a folder can have the same name inside the same folder, I had to download an example made by other person. Here is the link to that solution, and try it in my own inputs, because everyone is given a different input. So I had to test a solution that works with my input that is different from everyone else's input. So I tried his solution, but I changed something. Where I changed it? right here, this wasn't in his solution, but I added it to basically to give me like an idea of what was wrong with my solution. So here I could see all the paths that were less than, no, not all the paths, all the values, the sizes that were under 100,000, and compare them with the results in uh, my example, my solution, my code. So in my code, I wasn't getting the repeated values that his code, his solution was getting. For example, I think I can get an example right here. Maybe like right here. That is the same value because it is basically a folder with a folder a folder that has only one folder inside it, that has only one folder inside it, that has a file inside it. So it is basically a path with 3 folders and one file inside the last folder. And it was counting only once this path. And that happens more than once. Right here is another example. And this is why I was getting the wrong answer. So I got back to my code right here, to my solution. And if I am not wrong, if I am remembering it correctly, if I remember it right, I had to change exactly, I think it was right here. I think it was right here. Oh, so just to note that I had to change. I used the ChatGPT to generate some of these functions. I also used Copilot to help me in this. So, but those tools helped me a lot, but they weren't getting everything right. I had to change a lot of the functions that they generated, and even though the the these tools are pretty good, they aren't perfect yet, and I had to try many different inputs before they gave me a reasonable answer that I could, after they gave me that answer, I could work on that function or solution that they gave me and change some things to work in this example. So yeah, the ChatGPT or the Copilot didn't give me the right answer right right away, but they were very helpful. So what I changed is that after all, basically, uh, if I see an object in the let me think. yeah, basically each time it sees an object, or basically a folder, it will add this to the path and will iterate again recursively to that same new folder, the path to that new folder. Yeah, it's basically that. Hash table key being hash table hash table. Yeah, then the hash table key is the new hash table, and it will get through all the paths in the tree and adding to the paths variable and returning all the possible paths. So all paths, yeah. And the second part of the problem is it was just to get like this smallest folder that if we deleted it, that if we deleted it, it will free the amount of size, the right amount of size to the hard drive work well. Like the smallest folder that is big enough that if we delete it, it will free enough space in the disk to work properly. And here is basically the code to do that solution. So the second part was way easier than the first one. I think to solve this problem, I had to try more than 10 hours just to solve this problem. It was the most difficult challenge in the advent of code yet. So yeah, I'm very happy that I did it, that I could solve it. Even that I had to use a little help with this code right here. But yeah, even though I share a little bit, I am very happy that I could uh, make my own solution to this problem. So yeah, thank you for watching. I know that this is not this is not really optimized in any way. Probably it is very slow and so on, but it works. So thank you for watching. If you have any suggestions about what I could do uh, to improve my channel or my videos, I am happy to hear. And thank you for watching. If you like this video, please leave a like and subscribe. And I will do more videos about programming, about the advent of code, or other subjects related to it. Maybe some videos on statistics or machine learning, maybe some videos like that. Maybe talking about artificial intelligence or code in general. So yeah, thank you. Hope to see you soon, and bye.